Welcome to the AP Physics lecture on kinematics. This is going to cover relative motion. Here are the objectives for the lesson. So, why is there no such thing as true velocity? Right now, you would probably describe your motion as stationary because you're sitting down. But are you? Consider, the Earth is actually rotating, so you could argue you're moving east because that's how the Earth is rotating at 400 meters per second. But that's not all. Remember, the Earth is actually revolving around the sun though, but the solar system is rotating around the galaxy, and the galaxy is moving through space-time. So technically, are you moving? Well, I guess motion depends on how the problem is viewed or your point of reference. And point of reference is what we're going to be dealing with, because motion is always relative. But relative to what and how? This is a simple way of looking at velocity. Notice that this topic can expand to the idea of how light moves, and special relativity comes from this basic idea. So there's something called an initial reference frame. A frame of reference that is either at rest or stationary or at a constant velocity. Think about this as the point of view. In the picture here, you should see that the person can be seen as the inertial reference frame or inertial reference frame. The person sees the house, and he sees the house as moving because he is the stationary object. But if you were inside the house and you were from the point of view from inside the house, you would be stationary and the train would be moving. So that's what relative motion is. Essentially, motion is relative to another object, which anchors the coordinate axis system. That just tells us where we're putting zeros are at. There's two things in the relative velocity problem. Relative velocity involves objects moving in different directions. This problem also involves a diagonal motion. First thing, they are mathematically independent. What that means is an object can move diagonally. Its motion can be broken down into its x and y component. Think about our vector. Here is a force problem that you're going to do in the next unit. Here, the block is being pushed up around a ramp. Here, the student was able to solve two ways. They solved first in the x direction, which is down here for the acceleration. Then they went to the y direction to solve for the force. Notice, this is what they mean. Mathematically independent. The student was able to solve for the x component, then went to the y component. Mathematically, the x direction can be solved independently than the y direction, or you can do vice versa as well. That means the x direction and the y direction are mathematically independent from each other. They don't care. They don't affect each other. You can solve them independently from one of each other. But what about time? Well, relative velocity problems have similar time. That means the x and the y do actually share a important component, which is time. Although you can solve for the x and y independently from each other, both dimensions move at a constant velocity. So the velocity in the x direction would be delta x divided by time, and your velocity in the y direction would be delta y divided by t. Okay? I recommend that you go over the workbook of 1.E, the relative velocity, because that is going to give you a better insight on how it's asked on the AP Physics exam in terms of a free response or multiple choice. The whole idea of relative velocity is getting you to understand that you can break things into an x and a y component. So for the next chapter, okay? But the book here offers you some examples on how relative velocity works, but so far I haven't seen any of these on the multiple choice of the AP Physics exam. Okay, so in your class you might have did some of these problems. So this is a boat that is going across a riverbank, and it's velocity is actually going to change. So here, the boat heads north directly across the river, which flows west. The velocity vectors are shown in the green arrows. As it crosses the river, the boat is dragged downstream by the current. So the boat's initial velocity was forward, but it gets pushed by the velocity of the stream, so it moves diagonally. Likewise, if it went to the right, okay, it's going to end up right here at the center. So if it starts here on the right, it's going if it goes to the right, okay, this way, it's going to end up here. If it starts from the center, it's going to end up here. But if it goes, because the reason why is because of way the current is pushing. Okay, so make sure you understand what relative velocity is in terms of this problem. Okay, this is a typical problem you might see in your class. A boat has a top speed of 5 meters per second in still water, and it travels 100 meters downstream. And that has a current of 3 meters per second. So, how fast does the boat appear to move relative to an observer on the land? Well, what you need to know is that you add the two velocities together. The reason why is because its initial velocity, this is the velocity of the boat, and this is going to be the current. And this is when they are together. So here's your boat. Here's your boat velocity. Here's your boat's velocity. So velocity of boat, this is your velocity of the current. Notice that they are parallel here. The fact that they're parallel here, you add the vectors like normal. How long does the boat take to go downstream? Well, you should just set up the kinematics equation. Okay? The time it takes, we know that velocity is the change in the direction over the time. If you know what time is, you want to know time, and you know the delta x, so just make this substitution. Velocity was 8. The delta x was 100 meters, and you need time. So do the multiplication. T. Multiply t to both sides. 8t is equal to 100. Then divide by 8. Divide by 8. You get t equals to 12.5 seconds. Okay. The boat turns around and travels upstream to its starting point. So here, the boat's velocity was this way, but the river current is in the opposite way. Okay, so this is the 5, this is the 3, but it's a -3 because it's in the opposite direction. So this is its net 2 meters per second squared. Okay, oops, sorry, that's wrong. The arrow's wrong because it's still in the positive direction. Okay, all right. How long does the boat to go take? But again, set up the same equation. V equals to delta x over t. So set up the same way. It was 2 equals to 100 over t. Okay, they solve for it, they get 50 seconds. So what was the round trip? Well, we had this going upstream, up, then this is the one coming upstream, then this is downstream. Okay, so together they make 62.5 seconds. But again, this is when it's parallel. Okay, what happens now if it's in like this? So the current is the boat is going this way, but the current, the velocity of the river, this is the current. Remember, it pushes the boat. This is how the scenario is. Well, to get the velocity, you would actually have to set up this. But notice this is a right triangle, so you could set up the distance formula or Pythagorean theorem, however you want to solve it. So the velocity of the boat was 4 meters per second, and the river, the current was 3 meters per second. Using the Pythagorean theorem, right, a squared plus b squared equals to c squared, you can get this. This is the velocity due to the on the boat based on the current. Okay, how long? So we have this as the velocity. If you would like to see how long it takes, again, you would have to set up the kinematics equation. Okay, it's the same thing, right? It would be v is equal to delta x over t. But here they made sure they substitute in the right value. Okay, the delta x is your 50 meters because that is your how much the boat is traveling, and your velocity b is, this is just the horizontal speed. Okay, so this is how long does it take for the boat to cross the river. This is the horizontal speed, right? So this is just the horizontal time, right? Yeah, this is the time. Yep. How far downstream will the boat travel? Well, we know that this would be your delta y. So you could set up the equation. Velocity is equal to delta x over t, but it becomes delta y because now it's traveling down there due to the current. So rearrange it, you can get this. Delta y is equal to v times t. If you want to know this angle, you would have to use a trig operator, which is your tan. Okay, because you have the opposite and adjacent leg. If you want to know the angle, you just have to use a tan inverse because you have your opposite and adjacent. If you want to know how far it is from the shore, you would have to subtract it from 90 degrees because originally it's 90 degrees. Example 3. A boat has a top speed of 4 meters per second. The boat aims at a slightly angle upstream in order to arrive directly across the 50 meters from the current stream. So remember, the river is going down. So if he points the boat upwards, he's going to end up here, right? He's going to end up here, which is good because that is what his velocity should be. So again, set up the equation. You're going to get Pythagorean theorem. This is its. This is what it's his velocity here, which is 2.65 meters. And if you want to know time, again, you must use velocity that has the same direction as the displacement. You cross the river displacement. You use the cross river's velocity right here. It's 50, which is still the distance, and the v is 2.65. This is how much time it takes. Good. This time, if you want to know the angle, the fact that you have this, the fact that you have, let's say, your opposite, which is this. Where is that opposite, which is down here, and your v of your boat was your 4. So this is your opposite boat, and this is your tangent boat. No, sorry, not your tangent boat, your hypotenuse. This is the reason why you use the sine operator here. Remember, sine theta is equal to opposite over hypotenuse. That's why they use to get theta, you have to use the inverse sine. Okay. This is just some trig for you here. What angle will the boat from the shore? What angle as measured from the shore does the boat follow? Again, you have to do 90 minus that because that is the difference there. Okay. Again, these sort of boat questions are not on the AP Physics exam. Okay. But this is just something that I just wanted to cover for you guys in case you had questions in your class if your teacher gives you some of these vector questions. Okay. But that's it.